Hi. Okay, if you ask me about the theory of three-phase motor, so let's talk a little about it. Okay, so three-phase motor are actually built from three coils that are connected in the way that I'm painting it now. I'm painting it like this because there is exactly 120 degrees between each of the coils. Now about the motor itself. It is built from two parts. One of them is called the stator, and the moving part inside is called a rotor. Now in three-phase coils, so this is actually a magnet that is divided to 3 or 6 or 9 or whatever, but it depends on the number of coils that we will have on the outside area. So if we have arranged it like this, let's call it coil number 1 and 2 and 3. So inside the stator we will have exactly the coils that are divided by 120 degrees. So we will have here coil number 1, and here we will have coil number 2, and here we will have coil number 3. This is only if we are talking about something that it called three poles, because three-phase motor can be built from 6 poles or from 9 poles. The number of poles is not different about the number of coils. So if you will have 6 poles, so we will have one coil, but the coil will be divided into two parts. And it will be the same coil that is divided. And if we are talking about 9 poles, so each of the coils will be divided into 3 parts. And here, if it is 9 poles, so instead of 3 parts, we will have 9 parts. And also the magnet, or let's say the rotor, will be divided, depends on the number of poles. Okay, so if we will have 3 poles, so the magnet will be divided into 3, and if we will have 6, it will be also the rotor divided into 6. Okay, so now we can see something that is strange, and it is that we are applying voltage just at the same time into two places. What I mean that if this coil get the plus and this coil get the minus, this coil will be disconnected. And this is the way it works. We are changing the power, and we are changing the disconnected coils every time one of them is disconnected. So if this is let's say state number 1, so in state number 2 it will be different. It will be like this. In state number 2 we will apply plus here, minus here, and this will be disconnected. Okay, and this is actually the moving phase. The phase is changing, and each time only 2 coils are working. or apply the magnetic force. And how this is done? It is done by something that is called half bridge. Half bridge is a way to apply power, for example, to motors. So I will write and explain. This is usually N channel and this is N channel. Not always, because sometimes this can be P channel. P channel is how exactly this MOSFET is powering up. But usually they're both symmetrical and they're both N channel in order to keep the symmetric of the power to the motor. So this will be driving by some driver, and the driver can do all the things that we need. What are the things that we need? We need to apply to this output that is going to phase of the motor. We need to apply to this part or plus or minus or disconnecting it. So we have 3 ways to do it. Or this upper transistor is conducting, so we will have here plus, and this is not conducting. Or this is conducting and this is disconnected, so we will have minus. Or they are both disconnected, so we have nothing in this part, and this one is going to the coil, and we have 3 of this, so we will have 3 drivers the same. So I will draw just another one in order not to do too much mess on this paint. Okay, so this will be VCC, this will be GND, and this will go to this coil. And we have another one that is connected exactly to the other phase that we have. Okay, so here also we will have a driver. Okay, and this will be also N channel, and this will be N channel MOSFET. Okay, so the difference between the number of poles, I will give 2 major things about it. First, if we have more poles, we can apply more torque or more power to the same motor, because each change it will do a little step. If we're talking about 9 poles, so we will have to apply 9 changes in order to do a full rotation of the motor. Full rotation in 9 poles, we need to do 9 switches of these coils. But if we have 3 poles, so we need to do only 3 changes in order to do a full circle. Now I have here a motor with 6 poles, so I will show that in order to do a full circle I need to do exactly 6 changes. I will show it in a second. Okay, so this is the motor. I have a pin here, and now we will see I have this 3 phase here, and I will switch the power into different coil. Each time 2 coils will get something else, and we will see how it is moving. So I start with 1 plus and 3 minus. You see it is moving, and then 1 plus and 2 minus going to this way, and then 1 minus and 2 minus and 3 plus 2 minus and 3 plus, do it, moving this way, and then 3 plus and 1 minus, 3 plus and 1 minus, and then 1 minus and 2 plus, 1 minus and 2 plus, and then 2 plus and 3 minus, 2 plus and 3 minus. It is moving, and then 1 plus and 3 minus, 1 plus and 3 minus, and then 1 plus and 2 minus. We can see that each time it is moving one step ahead, and then 2 minus and 3 plus, and then 3 plus and 1 minus. And that's all. This is exactly how the motor is moving. Each time it gets to different coil, different voltage and direction of the current, and it is moving step by step like this. Thank you.